Hey guys, today we're going to look at another problem. So this problem's rating is 1800, and as always we are going to introduce this problem by explaining the example here. So here is the example, and for the input there are two numbers, right? The first number is the number of numbers in the array. We have 5 numbers in the array, and we can be sure that all of them are unique. And this is k. We can introduce what is k later. So now we have a array, right? 2, 1, 3, 5, 4. So there are two people in the game, and the first one pick numbers first. So he will pick the largest, which is 5. So 5 is out of the game, and we mark 5 as 1, right? Because it is picked up by the first player. And then the one number around 5 is going to be taken out as well. So this guy is marked as player once, and this guy is also marked as player once. So these three guys are taken by player 1, and now it's player 2's turn. Also, player 2 is going to take out the largest in the game, which is this one, and we are going to mark it as player 2's, and we are going to take out the one number around this guy. So we don't have any number to the left of this number, so nothing happened there. And to the right of this number, we got 1 here and mark it as the second players. So we have 2, 2, 1, 1, 1 here. That is the output. The same goes for the second example, right? So I will not spend the time to iterate on this. So let's go straight to the solution, right? So we are going to have two kinds of operations. The first operation is look for the largest one in the current array, right? Let's say for this array, the largest is 5. How can we find the largest? And then after we take out the 3 numbers, how can we find the largest in the rest of the array, right? How can we find the 2 here? So because the size of the problem is, let's see, is 100,000. So the time complexity of this operation is bound to be log n, right? We had to find the largest number in the array in log n time, so that we can repeat it for n times. And we in this way we don't get a time error, right? And the second operation we need to support is delete, right? After we find the largest number in the array, we have to delete it from the array. And also the k guys around this largest number, we also need to delete them, right? We also need to support this operation at most log n time complexity, right? Because we need to delete them n times. So that's the operation repeat for n times. So how do we support these two operations bounded by the time complexity here? So we need to choose the right data structures. So what kind of data structures are we going to choose? Here we go. First, we are going to use a set here, right? So we are going to put all these numbers into a set, right? And for C++ set, you can get the largest number in the set in log n time, right? Let's say you put all this number into this set, and you just let's say the set name is SE, right? You just need to call SE and get its prefix, right? This guy is the largest number in the current set, and you can delete the any of the number in log because you already find the number, so you can easily delete it in log 1 time, right? Or so that's how we find the largest number in the array. So the second operation we are going to support is delete, right? We need to delete the ones around x, right? For example, if we find the x here, it's 5, and we need to delete these two guys. If we only have this one data structure set, we don't have ways to know which ones are around the largest one, so that we can't delete them. So we need another data structure, which we are going to use a linked list. So let's say we have a linked list like this, right? And we are going to find the largest number by using set here, and we can know that the largest number is 5. So we are going to use a linked list, and we can find this node in log n time, right? And then we are going to use its pointers to get to its previous node and delete it as well, and use its second pointer, which is pointed to the next node, and find the next node and delete it, right? So hopefully you already know the implementation of a basic linked list. It will be look like this, right? This is the let's draw it another way, right? The there are going to be 3 fields in a node. The one in between is the value field. It's going to save 3 here, right? And the first field is going to save the index of the previous node, right? Excuse me. For example, we have an index for these 5 nodes here. Let's say 0, 1, 2, 3, 4 here. These are the index. And this guy is going to point at 1, so its value is 1. It's the index of its previous node, right? And this guy is going to actually yeah, and that's okay. So the next pointer is going to point to index 3 here, right? So this is the basic implementation of the linked list. But when we want to find a specific node in the linked list, it takes O(n) time. We need to traverse from the first node to the last to find the specific node, right? So we need to improve it. So we can, instead of having a index here, we are going to use a map to implement the linked list. That means we are going, let's say we have a node here, and the node is going to be a tuple in the map. So for example, let's say we have a map, its name is MA, right? And we are going to give this map key 2. 2 is the value of the node, and the value of this key value pair is 1, is 0, 1, -1, and 1, right? What does it mean? 0 means its position in the initial array is 0, right? And -1 means there is no node come before this node, right? So this is the pointer to the previous node, and this is the pointer to the next node, which is 1, because the key of the next node is 1 here, right? And let's take another example, this guy. So we are going to have another key value pair in the map, which the key is 1, and the value is 1, because the index of this node in the original array is 1, and the previous node key is 2. So this guy here is 2. And the next node's key is 3. So we have a 3 here, right? In this way, if we want to look for, let's say, look for 5, we can instantly find this node by just access the key 5, right? So it will take only O log n time, right? Actually, this guy is log n, right? And after we find this node, we can just travel to the previous one and travel k times, right? And overall the travel time is bounded by n. You can at most travel n times, right? Because the length of this array is n. So that's okay. So in this way, we can find a node in O log n time and delete this node in O 1 time, right? And we can repeat this process for n times. So we solve the problem perfectly. So just to remember that if we want to delete a node, we had to um, delete in the linked list and also remove it from the set so that the set always have the most updated version of those numbers still in the game, right? So I guess that's it for today. Thank you for watching. Hope that helps. Goodbye. See you next time.